Hello, I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Dr. Dirk Kesselgruber, Chief Technology Officer at GKN Automotive. On today's episode, we'll discuss GKN's electric drive technology. We hope you enjoy this episode. Welcome to the podcast, Dirk.
Hey, nice to meet you.
It's wonderful to have you here. The backbone of the growing electric vehicle market is the electric drive system. Without the electric drive system, we're not having electric vehicles. GKN was the pioneer. You were the original one doing the electric drive systems. How did this come to fruition? What did the company see that it decided to move into this market that's now rapidly expanding?
Grayson, it's actually a good question because we are not naturally coming from an engine manufacturer side or whatever. We're coming from driveline and from all-wheel drive products. And the very early electric drive system actually have been electrically supported differentials. So where our first customer just applied an electric motor to the differential gearbox to provide rudimentary all-wheel drive features. And naturally, if you also then look into where electric drive system come into the big market, it was on plug-in hybrid first. So, and a lot of these, let me say, mid-range cars and higher range cars provided all-wheel drive just with an electric axle at the rear, providing all-wheel drive functions as is. As requested, and then also providing electric drive capabilities. So naturally, GKN with the heritage in driveline and in all-wheel drive was actually a natural pick. And if I look into our history, our first e-drive application was in the year 2002. It was a very small, compact Japanese car, a Nissan Cube. And that was actually a pure electrically supported differential. And since then, our electrification journey started. Starting small, starting on secondary drive axles, starting on all-wheel drive features only, and now we are in main drive systems and having a complete portfolio and offering.
You've been in the market for 22 years. That's over 2 decades. It's really impressive. You mentioned hybrid. So from a technical perspective, when you're developing an electric drive system for a pure plug-in electric vehicle versus a hybrid, or I'll even throw another curveball at you, a plug-in hybrid. Is it the same electric drive system, or do you have to build bespoke ones for each type of vehicle?
It depends on your, first of all, every unit is bespoke for the specific car manufacturer's platform because it's package constrained, is how the system interacts with the electronics and the drive philosophy of the vehicle, etc. Generally, you have carryover, you have modules and building blocks that they are the same across different OEMs, so you have kind of a platform approach. But when you ask between hybrid, full hybrid, plug-in hybrids, or BEV, it's a question of the architecture, what the drive system looks like. So a standard two-wheel driven hybrid car has an electric motor directly attached to the combustion engine with a specific gearbox, with a dedicated hybrid transmission, or just a serial version in the normal drivetrain. If you go to all-wheel drive driven cars, you see more and more vehicles having a so-called P4 hybrid, where you have a full electrical axle at the rear, for example, which is completely electrically driven, and a combustion engine or a hybrid engine in the front. And so these units at the rear are not any different than on battery electric cars. They sometimes have a few different features, but per se, it's pretty much the same. It's an electric drive unit consisting of an electric motor, a reduction gearbox, and a power inverter, right?
You have a little bit of design depending on who the customer is, the type of vehicle. So that I complete from a bespoke perspective. But how about from a software perspective? Is the software engineered differently for the EV versus the BEV versus the hybrid?
There are common denominators when it comes to lower level topics like safety, diagnostics, those kind of things. But when you get into the control algorithm of the EDU or the drive unit, then it's very, very much depending on how the OEM is using the drive unit, when it's being exposed, how it's being integrated in the overall powertrain philosophy, how the energy management works, etc. And each OEM, for sure, also for differentiation, has its own philosophy, its own platform approaches. And so the functional software is actually bespoke. That's where we are really fitting the unit for purpose. We bring our own experiences, clearly, in which areas the unit operates the most efficient one, where do we see the best peak performances, NVH characteristics, so the acoustic experience of the unit to support and also the customer to have the perfect integration. But at the end of the day, our customers will get their own drive unit that it works the best for them.
Do you work hand in hand with your customers to develop the software? So you work with their software engineers and your software engineers to develop the most ideal software for them?
That is very different as well. It depends also on which software the OEM found their specific differentiators for the end consumers, and where they found it's more worth to let me say use the experience of the dedicated supplier, and the range is also very wide. It's going from a pure, let me say, functional requirement level down to very detailed software specifications. So the range is very wide, and we need to adapt to all kind of collaboration setups, which is good because at the end of the day, the first thing is that the OEM wants to differentiate to the other in front of their individual consumers. But they also want to master for sure their platform. So there are areas that they really want to keep control on to standardize across all the different vehicle segments. And there are other elements that are differentiating them from other brands to provide specific driving experience. And we are in this field of collaboration from day one. And we can provide, let me say, our competencies to the level that the OEM requests, right? So we can go from a pure software integration service to an end-to-end full eDrive system, software system, with all functionalities that you can imagine. So we have the full library actually in hand.
The neat thing about being in your seat is you're learning a lot. You're experiencing a lot, and you're learning a lot. How are you applying all of those learnings? It's just constantly working to update your product, make a better product, a more efficient product from all these vast learnings that you're gathering?
I think we are learning, let me say, project by project, and then also across the OEMs. That's absolutely right. The general element where we condense learning is in product requirements, in our simulation models, in our system layout processes, etc. So over the massive number of applications that we in these 20 years have executed, we learned a lot, you're right, and that's also why we have relatively mature or very mature system design processes that are covering almost every imaginable driving situation. And also, let me say, to master the challenge of efficiency under all conditions and squeeze out the maximum of performance on a cost-effective design. That's all going into the math of how you lay out a system, into the catalog of requirement, what you expect from a product, how you decompose it, how you integrate it, how you source subcomponents and make subcomponents. Yeah, I think that's clear. It's a good question. It's over 20 years we were collecting a few things.
You could find a few patterns. You talk about performance efficiency. Does that come down to software, and does that impact the driving experience? Perhaps you have one customer that likes to make cars that go fast, and you have another customer that likes to make comfy cars. Is that all being controlled by software?
Well, at the end of the day, software is only algorithms and code. At the end of the day, you need to translate this code into physics and reality, right? So whatever you want to achieve, the physical product needs to satisfy, right? You cannot make a race car drive system and then just provide 50 horsepower of output power, right? You can scale it a 500 horsepower unit and scale it down to 50 to limit it, but you cannot go vice versa. So you need to understand the mode of operations and the performance aspect that you want to achieve under all potential control conditions. And then you lay out your product that it can be satisfied. But I think optimizing this point to what you really want to achieve is crucial, because at the end of the day, you cannot protect for everything. It's nice to scale everything by software, but you need to pay it in copper, in magnets, in silicon, in everything. So you need to be very clear on what you want to achieve and what is the range that you want to cover with your software controls. So, and as I always said, everybody's on the software point, which is absolutely crucial. But at the end of the day, physics needs to support that. And physics costs the money in the car, and it's having the weight, and it's having the critical materials in there. So there's always a trade-off between cost, your sustainability targets, and your control performance that you want to achieve.
Well, that's a very valid point. You're not going to optimize a Class 6 truck to go around a racetrack. It's just not going to happen. The physics won't work.
Yeah, and at the end of the day, I think that's mastering the vehicle overall. I think we have a lot of experience in driving dynamics. We understand how we can control the natural steer behavior and improve traction in curve and off-road under all conditions. But the perfect balance of the vehicle is a mix of everything, right? Is a chassis tune, is a geometry and kinematics of the whole suspension system, is a weight distribution of the body. It's a perfect balance of battery size versus handling performance. So this is the art of the OEM decomposing then the expectation to a perfect EDU, electric drive unit. And then it's our mission to satisfy this perfection in the best way we can.
So you're satisfied for the best project, but then where does thermal management fit in this? How do you manage thermal management for a BEV?
Well, we have a couple of elements in thermal management that we directly influence and some where we are part, let me say, of the overall cooling system. The OEM has, usually we always think in system layers, right? So the top layer is the functionality of the car. Then you have a decomposed layer of your vehicle system and their domains. And within the thermal management in the powertrain, you will see the drive units, you will see the battery pack, you will see power electronics, etc. And they are all, let me say, managed to the current conditions and the expectations by the vehicle. But when it comes to our drive unit, we have also a lot of these measures under our own control. And there's first of all the efficiency of the motor itself, then our local cooling system, water jacket, oil cooling, active, passive, so we can scale cost complexity to performance. And then also when we look into the power electronics is a question of how many losses we create. And the two dimensions are being driven by how I do control software, and also what substrate I use for my power module silicon, right? I can buy silicon carbide, low losses for bigger money. I can stick to possibly a lower cost variant, but applying smart control or both. And so we have big influence in how a drive unit is heating up and cooling down by perfectly matching the way we control the unit to the current situative demand of the drive control. And I think that's also important that we are servicing this to say, what is your sweet spot? And your sweet spot changes depending on where you are, what your current immediate expectation to the drive system is. Are you racetrack? Are you on long distance? Are you waiting? Are you holding? Are you accelerating? And by adjusting the software to each of the individual scenarios, we can optimize the thermal management and the efficiency of the unit.
Efficiency is the key. You're providing value to your customers. The value is clearly resonating. This is amazing. You've been doing this for over 2 decades now. And today, this is today. There's over 2 million vehicles on the road today utilizing the GKN electric drive system. How are you able to secure such a large market share? Is it just the ability to learn, leaning into the innovation, the thermal management, the software? What is it?
Well, it's actually, we are in very early. We are in on products that are still in the market. We're winning new businesses. We are relatively selective in which businesses fit the best to us. We are not, let me say, our ambition is not to take on everything and grow just by the purpose of growth. We want to still be in the area where we can contribute with our engineering competencies and our all-wheel drive competencies. But over time, then it's collecting a pretty sizable share. And that's also important for us to secure the technology level going forward. But it's an early engagement, is the engineering know-how and the trust of customers. And I hope and I'm convinced that to most of the cases we are delivering also according to expectations. So.
What do you feel that your competitive advantage is for electric drive systems over your competitors?
Well, our core competencies is possibly in the legacy and the heritage of driveline and all-wheel drive. So we learned how to deal with electric motors. We learned how to deal with electronics, but we were starting from day one to understand the powertrain. And the driveline is really to transfer and control the torque for each of the wheels. And with that, we are very, very close to what the vehicle and chassis and driveline requirements are. From there, if you are adding then capabilities, technologies, it's easier than to grow up from a component only and start to anticipate what is needed from the vehicle level. And this actually didn't change. We were adding possibly more emphasis on efficiency. We were adding more emphasis on high voltage safety aspects, etc. But the fundamental understanding of how a car drives, what is the experience, what is the efficiency measures of this one didn't change so much. And so for us, it was relatively easy to translate that into the new electrified world. Yeah.
The electrified world's great. I own an EV, and it drives a lot differently than my old internal combustion. And I like driving with one foot with regenerative braking. I think it's the greatest thing. And my father-in-law drives the car and he goes nuts. He's like, I'm old school. I want to use the brake and I want to use the gas. But and then in different EVs, so you drive, say, Model A EV, you drive Model B EV, you drive Model C EV. The regenerative braking systems are different. They some are the California roll, some have the whoa that really starts. How is that developed? Who makes that decision? Is that your customers that are making that decision?
Yes, that's a vehicle manufacturer, because they control the driving experience, and this is a pure decision and strategy that you want. Most of the cars, by the way, if you go into EVs, you can select. You can even choose the level of recuperation and how much you need to actively expose the pedal versus how much you do by lifting your gas pedal, let's call it this way, or your acceleration pedal. Just need to find some new wording. But that's purely the OEM. We respond to this by let me say, a control demand, and we are adjusting our system to the condition that the vehicle level system requests. But that's philosophy, because it's pure driving experience. Yeah. We have for sure our own philosophy of doing this, because we are making demonstration cars. We build our own vehicles to develop our technology. We do not always wait for a requirement from the end. We also go proactively into those kind of functionality. But finally, it's the OEM that gives this expectation. Huh?
Is that a software layer you develop? Because you're right, you can have regenerative, non-regenerative. So it's built into your hardware, and then there's a software layer to determine what level of regenerative braking there is?
Yes. That's even a software layer that in most of the cases, and almost all the cases on the vehicle level or in the powertrain domain, because the level powertrain and chassis domain, because recuperation is not a question of the powertrain only, it's a question of blending between brake apply, recuperation from the powertrain, and the transition, because you need to blend the friction brake system, so the wheel brake system, and your drive unit seamlessly, that you have a good driving experience. And if you make your pedal, you also want to have the right feedback and not being disturbed. So just by the nature that it's arbitration of multiple domains in the vehicle, the control is on the vehicle level. So and shouldn't be with the EDU.
Let's zoom out for a moment, and let's just say you're sitting there on a whiteboard, or you're sitting down with your technical team, and you said, "Gentlemen, ladies, we're going to develop a new electric drive system." What are you looking to improve? What are you looking to do differently?
So actually, it also, let me say, depends on where you are coming from and what is your target customer. I think from an industry perspective, to get wider penetration of electric vehicles in the market, it's all about cost and hurdles of entering the electrified market. But it's possibly not the drive unit, the mandatory fact that's driving this one. I think there's a lot of innovation to be expected around the battery, integration of electronics, etc., and scale. From a GKN perspective, our next generation of e-drive system is all about driving dynamics and off-road performance. So we see the first wave of electric cars was everybody was satisfied that cars driving electrically. It was a challenge. I think this is now in place. I think it's now a base expectation that electric car drives nicely. Now all the old, or let me say former features of driving dynamics coming back to electric cars as well. So now you have a very heavy vehicle, but you still want to have nice handling performance, good agility on a curvy road. You want to have your battery electric cars performing equally perfect in an off-road condition, even with I would always say this with the 3 wheels lifted up, but actually it's only 2. But you want to have this locker versions, this torque management. Yeah, you now have the ability to control just by software front and rear. But if you don't want to spend excessive money with dual motor architectures, etc., you would like to still having nice off-road performance also on single motor or dual motor vehicles. And so our development goes completely into these kind of torque managers and features. That's our key focus. It's a bigger challenge than in the past because now they need to shrink into a very small electric drive system. So it's a bit of a challenge to get them sized right, but still performing perfect. But that's our innovation layer. And with that also the great features for experience, right? That you really leverage these actuators to a perfect driving experience. And there are other standard elements that we always look at. It's the key element is cost. Get cost down, find the optimum design with the lowest level of material exposure, lowest level of critical materials exposure, and further increased efficiency. These are the natural imperatives, but when it comes to experience, it's clearly off-road and driving dynamics.
So off-road means a lot of things to a lot of people. One thing, when you first said it came to my mind, you see the videos, I see them on YouTube, of the individuals with the souped-up Jeeps rock climbing, and they're going up these really steep mountains, and then you have the other individuals that perhaps want to go fly fishing, and they're going in a national park. Are you looking at the emerging electric SUV market? Because right now we have the passenger vehicles, then we have the big craze now around the pickup trucks, and it seems to me the next logical breakthrough will be on the SUV market. Is that where you're looking at from an off-road perspective?
Yeah, it's both. If you go into regular cars, for example, you will see, like in the past, high performance variants. So you take your classical sedan and then you get a very nicely super high powered sport version of this one. And if you go on a racetrack, lap time matters. And so let me say, as you are now carrying a few 100 kilograms more with you, you need some good devices that keep you on the track and provide the same level or even better level of agility. So that's one application. It's just made for a standard car, which is going into the extremes and provide super sports vehicles, the off-road segments, and clearly. So where you have really the traditional SUVs, but even more into the real off-road vehicles where you have multiple lockers in the past, front, rear, middle, whatever comes. Now with electrification, it's a fantastic opportunity to make a really big difference in this market, also from a drivability perspective. You're right, it's climbing up the hill, right? And then if you go for fishing, you have a nice locally emission-free vehicle that doesn't make a lot of noise, and you can quietly move to the next lake, park it, and you have a 230 volt power supply to bring all your gadgets with you. I think it's opening up a really nice experience by the fact it's electric. Yeah,
it's great. You didn't disturb the bear. You can see the bear. You can see nature because he won't hear you coming. He'll just be there in his natural element.
Yeah, exactly. Unless you're not losing your key inside of the car, it's all good.
You don't want to do that. You don't want to get locked outside because you never know, the bear could be hungry, right?
Exactly.
So that's a really interesting way. So you have the on-road business for GCAN, you have the emerging off-road business. In your opinion, what is the best way to approach electrification from a product development standpoint? Do you look at it as market segments when you approach it?
That's we do multiple areas. Market segments, yes. Customer requirements for sure. We also do anticipate trends. So what's coming next? What are the big trends going to? And one of these off-road things is clearly the trend for outdoor sports and recreational aspects, which will go big, and people are prepared to pay for features. I think that's a good opportunity. We also look onto forward-looking, in particular, on sustainability. So what is our long-term, let me say, approach also to make this product into a recycling economy that you can tear it apart, minimize exposure of critical stuff, etc. That's also important for us because there's no way back. I know that the market is currently having some issues of adoption of electric vehicles by multiple reasons, but the end game finally will be electric. And so, and with that, there will be the expectation of having not only local CO2 emission free, but also overall sustainable product life cycles. Yeah. And I think that's also important for us to consider that in the product development.
I was every market has growing pains. It's normal in an emerging market. There's always going to be growing pains as the market grows. From a trends perspective, you mentioned outdoor. That's a really good trend. What other trends are you seeing that could possibly impact GKN's business?
Well, at the end of the day, there is always the big challenge of the urban transportation and shared mobility. What is not directly linked to electrification, but is implicitly linked to electrification, because naturally, let me say, local emission rules will let me say, keep in the future combustion engines out of urban structures. It's also been shared mobility, possibly not. I use a shared car and I just rent it where it is because it actually didn't take off. It's interesting. So the taxi business is still a taxi business. If there's a driver in there or not, it's still the same. But I think transportation of people and goods inside of urban areas is going to be very important. It's not only to transport goods, but it's also to transport people at the size of 4 to 8, having the local or local and decentralized transportation in the cities. And so for us, for electrification, the light commercial vehicle segment is very important because we see there a lot of potential applications going forward. They might still have a driver, at least for a few years, but they still need to be locally emission free and need to be prepared to be ultra flexible and solve mobility issues in urban environment. Yeah? That's clearly also an element.
The commercial market, especially that last mile, middle mile, whatever technical term you want to do, is definitely emerging. It's going to go electric. The big thing that it's going to be the weight issues, especially if you're moving a lot of packages of dealing with the weight issues, then the road issues. But that's going to be figured out. The one thing that everybody generally agrees with, the opportunity to electrify from a market perspective is very large. In your opinion, how large is the opportunity to develop electric vehicle system technology? Because it seems that we're still in the early innings of a 9-inning baseball game of where this technology is eventually going to go.
You mean in particular in the light commercial vehicle area?
I would say across the board, because the technology is going to go across the board. It's not going to be limited to just one class of vehicle. It's going to go completely across the board.
You mean, let me say, entering also segments where today it's almost unimaginable to electrify.
Yes.
Well, yeah, at the end of the day, it's all about how you store your energy. It's less about how you drive your vehicle. Even if you go into supersize ships or whatever, electricity is generated and then the drive systems are already electric. I think it's more about the challenge of power density of your energy storage. And this could be a challenge longer time for the big off-road vehicles, so bulldozers, etc., or construction vehicles. I found it even challenging in big scale to consider that in long-haul cars. But you still have opportunities here to replace your storage with fuel cells, etc. I think that we will see in the market what will be the sweet spot finally for which segment. Yeah, there will possibly some segments like airplanes or whatever that will stay long time on e-fuels because they can afford. They need the power density. They still need to be CO2 free. And there's possibly then an area, let's say on light commercial vehicles or let me say last mile delivery trucks from where you go from battery into something else. I think it's currently a big philosophy out there. We have fully electric heavy duty trucks. You have variants with fuel cell, and there are others who don't believe that electrification is possible at all in real life. But finally, to meet the CO2 targets in all the countries, mobility will be electrified in the very, very last consequence. And the innovation will be in how you store the energy. That's where the big end game is. Electric motors you can scale up and down. That's not a big deal. Yeah, but kilogram per kilowatt hour battery storage or energy storage, that's a massive changer, a game changer. Then
you gave the honest answer, and you gave the right answer, and you gave the answer that not a lot of individuals talk about is energy storage. You hear these conversations, electrify everything, and then, well, what's your microgrid strategy or what's your storage strategy? Oh, somebody else will figure that out. But you're right; it is going to be a large part of it. How do you see the storage rolling out? Do you see it being mandated by governments? Do you see the private sector is stepping in? Because if we're going to electrify everything, there has to be that give and take.
I still believe a little bit in the market dynamics. If you see what's happening, let me say in Europe with solar roofs, etc. In the meanwhile, everybody who has its own house and electric car also puts solar panels on the roof if people can afford. It's always a question of affordability. But you see prices coming down, volumes coming up, and it's getting more and more affordable and going into middle class and then into a wider population. I'm not sure that mandating it is going to help, because the investments coming along on an individual basis, but also for companies, are huge, right? If you are mandating it, you also possibly, if you do that centrally from the government, you're not necessarily coming to the best technical conclusion. So, because it finally needs to survive in the market on cost, on quality, on reliability, on practical use. And politics are not always the smartest in the world. They are smart, I don't take that into question, but it's not, let me say, should not, my personal opinion, dictate the technology level. I think we are going to be very philosophical, and it's far outside of the automotive scope that I'm working in. But I find that with regenerative energy creation, we will decentralize our energy storage. We will increase the capacity of energy storage, because energy will not be there at any time under all conditions. So we need to balance out the spikes where we have energy to drain from it when we need it. And there will be very, very different carriers where you need very low cost in mobility and transportation. It's all about affordability, but then with technologies that make it cheaper and smaller. And you will possibly have bigger stationary solutions that are technically completely different to operate, let me say, stationary energy requirements. But it will definitely, the capacity will be huge. With 20 years going forward, the amount of kilowatt hours in the market of all kind of will be incredibly big. Yeah.
It's going to be fascinating to watch the energy storage market grow and the role that e-drive systems play. I think e-drive systems are fascinating. They're only going to grow, especially if you go across different classes of vehicles. In your opinion, Dirk, what is the future of GKN Automotive? Will you continue to invest and innovate around e-drive systems?
Well, actually, I think we are expanding our futures around this driving experience. I think that's where we were coming from. Actually, the first iShaft or the drive shaft, not iShaft, drive shaft that we made was for racing. So driving emotions is a big part of our heritage, and I think we will expand through that. Right? What will we add to this going forward? Time will tell us. But I think you should never lose your routes and your core, and build around this one. And I think then we will have a good journey. Artificially step now into areas which are completely off what we are doing today is possibly not what we will do.
What you're doing is working. There's over 2 million vehicles on the road utilizing your electric drive system, and that speaks volumes, especially in this fragmented supplier world in automotive. So you're clearly on the right track. I can't wait to see what you invent next, what you develop next, because something tells me that you're going to continue to innovate and you continue to invest in these e-drive systems. And I'm really excited to see as you go into large off-road and heavy industrial equipment of how that's going to work. And that has to get electrified, and I can't wait to see what role the GKN plays in that. As we look to wrap up this insightful conversation, Dirk, what would you like our listeners to take away with them today?
Well, at the end of the day, I think the takeaway would be, first of all, the electrical journey has started and it's not going to end. It's going to continue. I think that's very important. The second one is that us as a company, I think for us it was the right choice to be engaged in electrification early and to build on this one, because we see now it's a great opportunity for us to bring our heritage into the future and build on this one. And it was also a great opportunity to, let me say, open up new opportunities for us for growth and technology. The third one that software matters. I think we are transitioning into an era where software is going to be the dominating differentiator between vehicles, and companies like us who can master software have the benefit to contribute to this one. slightly different than in the former combustion engine world, where the mechanics were given the experience. Yeah, and I think electrification is not only an automotive thing. So all sectors having equal challenge and also fun, yeah, to go this journey and transform the world. We are happy to in the spot we are. We are happy to contribute, and I hope also that we continue to contribute in the future.
Something tells me you will continue to contribute in the future. I love the line, the electrified journey has started. Dirk, you are 100% correct. That journey has started. Today is tomorrow. Tomorrow is today. The future is GK on automotive. Dirk, thank you so much for coming on SAE Tomorrow Today.
Thank you very much. Thank you for having me.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.